Let's look at question 6a. Find the total number of different arrangements. So this arrangement is actually the key words for permutations. So you have to think of using permutation instead of combinations. So continue. Of the 11 letters in the word caterpillar. So let's look at this caterpillar. We focus on the letters that repeat. So we have 2A, we have 2R, we have 2L, and the rest is just 1C, 1T, 1E, 1P, and 1I. So first of all, what we need to do is we want to find the total number of different arrangement of the 11 letters. So that means you have to arrange all of them. So we put 11 factorial on top and we divide by the repeated letters. So we have 2A, hence 2 factorial at the bottom. We have 2R and hence 2 factorial at the bottom. And we have 2L and hence 2 factorial at the bottom again. By pressing calculator, you will get 4989600. Let's look at part B then. Find the total number of different arrangements of the 11 letters in the words caterpillar, in which there is an R at the beginning and an R at the end, and the two A's are not together. So we have 11 position. And you have to put R in front and R at the back. So for the A's, they cannot stay together. So it has to be separated. So what am I planning to do is I am going to find out R at the end. That means I'm trying to find out the total ways to put R at the beginning and R at the end. Then I'm going to minus with R at the end and A together. Okay, so let's take a look on how we do it. To put R at the end, the calculation will be, of course you may think of what is the calculations for R at the beginning and at the end. So you may think like this, you have 2, this is optional actually. You have 2R, so that is 2 factorial, but the 2R are similar objects. So whenever you have similar object, you have to divide by the number of similar objects. So divide by 2 factorial. So it ends up with 1. So that's why I said this is optional. So this is how we arrange R. So after arranging R, so we still have other letters to arrange in between. And if you look at the total numbers of letters that you're going to arrange in between, there are actually 9 of them. Hence 9 factorial on top of the fractions and divide by the similar objects. So bear in mind that we have arrange R at the beginning and the end, we still have 2a as the similar object, so we have to divide by 2 factorial, and we also have 2l as the similar object, so we divide by 2 factorial again. Okay, so this is the front part. Now for the back, let's look at the statement here again. R at the end and A's together. So again, to put R at the end, the calculation is like what I said just now. This is optional, so it is again 2 factorial over 2 factorial multiply with, okay, the idea of putting objects together is where we assume 2 of the objects that are going to stay together as 1 unit, and then the rest as single unit. So as you can see here, I put in blue box. So if we assume these two as 1 unit, so this will be 1 unit, 2 unit, 3, 4, 5, 6, 7, and 8. So we have altogether 8 units to arrange. So we call that 8 factorial. And we have to divide by the similar objects here. So the similar objects here is the L, the 2L, so 2 factorial. We don't care about the A first for these fractions. For this fraction, we don't care about the A. Okay, so as we have assumed A as a unit, the 2A as a unit. So that's why here we don't care about A first. Now let's take A into consideration in the next part. So in order to arrange A, you have 2A, so that is 2 factorial, but they are similar, so we divide by 2 factorial. Okay, so let me label down. This calculation is for the arrange of R, and then the back one is for the arrange of A. Okay, so now let's simplify everything. By pressing calculator, you will get 70560 as the final answer. Okay, so let's look at the third part, part C. Find the total number of different selections. As you can see, the keywords here, selection, is actually the keyword for combinations. Okay, so we have to use combination instead of permutation. Okay, so let's continue. Of 6 letters from the 11 letters of the word caterpillar that contain both R's and at least one A and at least one L. So as you can imagine here, when they say at least one A, that is more than or equal to 1A. So it can be 1A or 2A. So likewise, at least 1L means more than or equal to 1L, and it is having more than one scenario. So let's write down all the possible situations. So the first situation, we have 2R. Let's say I start with 1A, 1L. Bear in mind that we are selecting 6 letters. So after taking 2R, 1A, and 1L, we still need 2 others. 2 others. Okay, this is the first situation. The second situation is 2R, 1A, 2L, and 1 other. The third situation, 2R, 2A, 1L, and 1 other. And the last situations, 2R, 2A, 2L, and we don't need other letters. So let's calculate each of these. So in combinations, if you are selecting similar object, as in here, you are selecting 2R, so the calculation will be 1. Okay, so as there is no difference, or there is only one way to do so, as there is no difference between this R and that R, you know, so that's why there is only one way to select similar objects. Okay, so how about A? So you may think of you have 2A here and you are selecting 1, so actually that is for distinct objects. Again, in combinations, there is only one way to do so. For similar objects, you want to select one of it, there is only one way to do so. No matter which A you pick, so it ends up with the same. So only one way to do so. This is for A, selecting A. And likewise for 2L and you are selecting L, bear in mind, don't use 2C1. It is just one way to do it, so just one. How about others? So we are going to select 2 others. We have what it means by others. Let me write down here. The others that I put here is actually the remaining letters other than A, R, and L. We have C, T, E, P, and I. These are the others letters. So we have 5 of them and we are doing 5C2. We are choosing 2. 5C2. So end up with 10. So let's look at the second case here. 2R, one way. 1A, one way to do it. 2L, one way to do it also. You can just ignore the 1 times 1 times 1 if you want to cut the working short. So for 1 other, that will be 5 other, you choose 1, so end up with 5. And for the third case, choosing 2R, one way. Choosing 2A, one way. Choosing 1L, one way. Choosing 1 other, 5C1. So you can see we apply combination for distinct objects only. For similar objects, no calculation is required, or just put 1. So the third situation, 2R, that is the similar object. No calculation or put 1. 2A, 1. 2L, 1. So end up with just one way. When we total up the number of ways, we get 21 ways, and this is the answers.